Good morning, students. In this video, we are going to describe about the interrupt nesting. A multiple priority scheme is implemented by using a separate INTR and INTL line for each device. Each INTR line is associated at different priority levels. Priority level of processor is the priority of program that is currently being executed. Processor accepts interrupts only from devices that have higher priority than its own. At the time of execution of an interrupt service routine for some devices, a priority of processor is raised to the top of the device. Thus, the interrupt from devices at the same level of priority are lowered or disabled. Let's have two discussions over here: privileged instruction and privileged exception. What is privileged instruction? Processor priority is encoded in a few bits of program a process status word. Encoded bit can be changed by privileged instruction that write into processor status. This privileged instruction can be executed only while processor is running in supervisor mode. So that the processor in the supervisor mode only when executing operation system routines are going to be called as privileged instruction. Next one, privilege exception. User program cannot accidentally or incidentally change the priority of the processor. As well, user program cannot disturb the system operation also. An attempt to execute a privileged instruction while in user mode leads to a privileged exception. This is going to be called as privileged exception. So privileged instructions are going to be get able to execute only in the supervisory mode. Privileged exception can be made in the user mode. So these are the two different important things. Simultaneous request. Coming to the simultaneous request, the processor must have some mechanism to decide which request to serve or serve when simultaneous request arrives. This INTR line is a common to all devices. This INTA, nothing but the interrupt acknowledge line, is connected to a daisy chain fashion. Okay, so here we are going to discuss how this simultaneous request may be possible to accept by the processor and to process for the particular process of interrupt that we will discuss in the next video. Good morning, students. In this video, we are going to be discussing about the polling scheme in the interrupt. If the processor uses a polling mechanism to poll the status register of an IO device to determine which device is request an interrupt, in this case, the priority is determined by the order in which the devices are going to be polled. The first device with the status bit set to 1 is the device whose interrupt request is accepted. Sometimes a simultaneous request may arise over there. The processor must have some mechanism to decide which request to serve when simultaneous request arrives. Here the INTR, nothing but the interrupt request line, is common to all the devices, whereas the INTA, the acknowledgement line, is going to be connected in a daisy chain fashion. Let's see about the daisy chain fashion over here. So the interrupt request line is a common one. INTR is a common line which have been given over here for all the devices, whereas INTA is going to be a single line which is crosses one device to another. Here the INTA signal propagates serially through the devices. When several devices raises an interrupt request, this INTR is going to be active, whereas the processor responds by setting an INTA line to 1. This signal is received by device 1. Device 1 passes the signal to the device 2 only if does not require any service. If device 1 has a pending request for interrupt, the device 1 blocks the INTA signal and proceeds to put its identification code on the data line, so that device 1 that is electrically close to the processor has the highest priority. Such a way the daisy chain scheme is going to get processed over here. Let's discuss how actually it's going to be doing its process in a detailed way. And if some other arrangement has been made over there, if multiple requests are going to be get possible, so what happen, a arrangement of priority groups are going to be get formed over there. Here the devices are organized in group, and each group is connected at a different priority levels. Within a group, devices are connected in a daisy chain fashion scheme. So here if you're going to see about the device, all the devices are going to be called as INTA1 devices. Here we are going to see about a multiple INTR will be present over there, as well as INTA also going to be present over there. Such a way the devices are going to be connected in such a way, and each row is which consisting of an daisy chain fashion. So a group of devices which are be connected over there, and based on the priority arbitration circuit, the priority is going to be get enabled, and such a way the processor is going to do its operation and is going to satisfy the particular condition over here. Okay, here as per it is the advantage, if you're going to see about that, it requires a fewer wires than the individual connection, so that what happened, the advantage is also going to be improved over here, and this arrangement is going to be called as priority group daisy chain arrangement to overcome the simultaneous interrupt request. In general, the same arrangement is used when multiple devices can send interrupt requests to the processor. During the execution of an interrupt service routine of the device, the processor does not accept the interrupt request from any other device. Since the interrupt service routine are usually short, the delay that this causes is generally acceptable. However, for certain device, this delay may not be acceptable. Which device can allowed to interrupt its processor when it is existing or executing an interrupt service routine for another device? An IO device are organized in a priority structure. An interrupt request from highest priority device is accepted while the processor is executing the interrupt service routine of a low priority device. A priority level is assigned to a processor that can change under the program control. The priority level of a processor is the priority of the program that is currently being executed. When the processor starts executing the interrupt service routine of a device, its priority is going to be raised to the top of that device. If the device sending an interrupt request has an highest priority, then the processor accepts that interrupt request and stop the execution of the current execution and jump into the highest priority execution, and it's going to execute that process and it's going to fulfill that and return back after that highest priority work, and it takes the previous work and it's going to complete that particular task. Such a way the priority group arrangement is going to be working and satisfactorily it's going to complete the process task. Next, controlling device request. What is actually controlling device request? The following conditions we have come across over there, nothing but the condition codes which have been there. Three condition codes are going to be there: enabling and interrupt request, which have been present over there between the keyboard and the display. The following condition codes are KEN, DEN, KIRQ or DIRQ. Keyboard interrupt enable, display interrupt enable, keyboard display unit requesting an interrupt, or a display unit requesting an interrupt. There are two independent methods for controlling this interrupt request, enabling the IE things over here. They are at the device end. First one is going to be at the device end. This interrupt enable bit in a control register determines whether device is allowed to generate an interrupt request or not. That is the first one. Second one, at the processor end. At the processor end, interrupt request is determined by either a IE bit in the process status register or the priority structure. Based on that, it's going to decide and it's going to do the process of controlling the request. Such a way, the interrupt controlling request is going to be fulfilled either at the device end or at the processor end. So these are the two methods of controlling the request device request lines in the interrupt process.